Hello everyone, Gord here from Math Pickle, now from the Julia Robinson Mathematics Festival, where I've been working for the last year. I have, however, continued to make puzzles, and I'm going to show you one of my favorites. It was inspired by Alcuin, a person who lived 1200 years ago. It's the classic river crossing problem that inspired me. Here we have a cabbage, a goat, and a wolf. I'm not going to show you this puzzle. You can find that below along with all of these puzzles. We're going to look at the last one here. That's the one that is new. And here I'm going to choose 10 monsters. That's good. And I think I'm going to choose a boat of size 6. Your objective is to find a way to get all of these monsters from the left riverbank to the right riverbank. So, for example, I could just grab the monsters like this. I can hold up to 6 on this boat. I can move them across. Oh, but there's a problem. The 2 and the 1 were eaten. Why were they eaten? Well, the 2 was eaten because it is the largest factor of 4. And 1 was eaten because it was the largest factor of 2. So let's try this again. What happens if I was to take all of these numbers, but instead of, what happens here? Instead of the 4, I'm choosing the 6. Will the 6 eat the 2? No, because it is not the largest factor. So the 6, however, will eat the 3. So as soon as I leave, these monsters here will start eating each other if they can. So if I leave now, the 2 will be safe, but the 3 will be eaten. So this doesn't work. Okay, let's take out the 10 and let's take the 3. Okay, does that work? Let's see. Okay. Oh yeah, the 1, of course. So it looks like we should probably bring the 1 because the 1 is the largest factor of all prime numbers, including 2. So that didn't work. Okay, maybe you guys want to go and try this, but I'm going to try it once again, and I'm going to show you guys that you get to move back and forth with the boat. So for example, like this, does that look safe? Oh no, because the 8 will eat the 4. Okay, I'm going to remove the 10 and I'm going to take the 8 instead. That looks better. Okay, so I go across like this. I can unload all of my monsters. But if I go back again in the other direction, what happens? Well, unfortunately, the 1 will be eaten whenever I leave this side of the riverbank. And the 3 will also be eaten because the 6 will eat the 3. So maybe I should bring the 6 back with me and the 1 back with me. Is that safe? That looks safe. So I'm going back again. And now I can fit in all of them. There we go. Okay, so I've been successful. I've got all of them across the riverbank. But of course, that was a pretty big boat. That's hard to row. Can you do it with a smaller boat? A boat that can only hold 5 monsters, or maybe 4 monsters. So I want you to experiment. And when you're ready, in 5 seconds, I'm going to show you that it actually can be solved with a boat of size 5. So go ahead. Let yourself try that. You'll find the link down below. Okay, now I'm going to show you guys. I'm going to make this a boat of size 5. And how do we solve it? Well, one way to solve it is like this. We're going to take the 1, because the 1 can be eaten by all those primes. And then we're going to take the composite numbers 4 and 6 and 8 and 9. Is that good? Oh, but that's not going to work. That's not going to work because the 10 is going to eat the 5. So I guess I shouldn't take the 8. Right, because the 4 is already here. So I don't need to take the 8. Instead, I need to take either the 5 or the 10. That doesn't matter. Let's take that. And let's go over and unload. There we go. Now, can I unload everything there safely? The 10 can't eat the 5. The 9 can't eat a 3. The 6 can't eat a 3. The 4 can't eat a 2. Looks like everyone's safe. So then I can go back and you can see that I have successfully found one way. There might be other ways of using a boat of size 5. Can you do it with a smaller boat? So again, I want you to take 5 seconds. And this time I'm going to show you a way to tackle this problem in a more graphical way. So I'm going to start by noticing the connections between numbers. And any two numbers that are connected, I know that those two numbers, I can't take both of them. So for example, if I start off with, I'm just looking at the numbers 1 through 10, I know that I can't take both the 2 and the 1. I know I can't take both the 3 and the 1. I know I can't take both the 5 and the 1. And I know I can't take both the 7 and the 1. That's why all of those are connected. Which other numbers are connected to each other? So think, and I'm going to show you the next row. The next row is going to be those numbers that are connected to one of these numbers. That means that these numbers are one of their, what is their largest factor. So for example, 4, 6, 9. Have we got all of the numbers? No, there's one number left. The number 8 is not connected to that second row. It is connected to the 4. The largest factor of 8 is 4, so it would eat the 4. Now, we know that we could solve this with 5. There's an example. We could take all of those blue numbers and we could say, yeah, you can think of why that's going to be possible. Because we can take all of those, then we can row them over to that side of the shore, and we're in a pretty good space. We can leave all of those numbers, we can come back, we can grab all of the others. Okay, so pretty happy. We could also take these 5 numbers, but can we take 4 of these numbers? Okay, and the answer is yes. Here we go. We can take the numbers 4, 3, 5, and 1. And none of those are connected to anything else. We can take them all over, but we can't leave them all on the other side. And why not? Because the 3 and the 5 would eat the 1. So we have to bring back the 1, and then you can try it for yourself. You can solve this. So this is an example of a puzzle that I'm really happy with. And this came, of course, from being inspired by Alcuin from 1200 years ago. I encourage you to check out the Julia Robinson Mathematics Festival. I will also include the link to that website below. Take care.